Lesson 2.2, Part 2. Our job is going to be, we just have one job today. Given 3 points, they're asking us to write the equation of a parabola that passes through those 3 points. Okay, so like something you've done before in algebra. I'm trying to think, I don't know how much we've done it this year yet, but given 2 points, you can write the equation of a line, right? Like y equals mx plus b type thing. Well, this is given 3 points, write the equation of a parabola. What's standard form that we've been talking about in this lesson? Standard form of a parabola is, and I'm going to start that with a y equals, but yep, y equals ax squared plus bx plus c. We're going to use that standard form, okay? Now, in order to be able to write this equation, we have to be able to find a, b, and c. Okay? What do we know about ordered pairs that are given to us? Ordered pairs represent what kind of values? What's the order in an ordered pair? What? XY, yeah. So we are given 3 sets of XY here. Okay? We're given 3 sets of XY, and we're going to use those. Okay? So let's look at using the first one. Okay? My first ordered pair is -2, 32. Okay. Fill that into this equation. Every place I see an x, I'm going to replace it with -2. Every place I see a y, I'm going to fill it in with 32. So if we have the equation y equals, we're going to start with what? (32) equals a times x squared, a times -2 squared, plus b times -2 plus c. Okay, so what we have here is we have an equation that has an a, b, c in it. And that's going to be our goal eventually, to find a, b, and c. Now, I'm going to clean this up. A times -2 squared. -2 squared is 4. So a times 4 is going to be 4a. B times -2 can be written as -2b plus c. That's one equation. I'm just boxing it there so I don't lose it. That's one equation we're going to work with today. Okay? Here in a bit, I'll call that equation 1. Now, what else can we do? Can we repeat this process with the other 2 ordered pairs? I don't know if you guys see where we're going yet, but I'm trying to give you hints. So let's repeat this process with the ordered pair 1, 5. Every place I see an x, I'm going to replace it with 1. Every place I see a y, I'm going to replace it with 5. And you're still using this standard form. So y equals, so 5 equals a times x squared, a times 1 squared, plus b times x, b times 1, plus c. Clean that up. 5 equals, 1 squared is 1 times a. Well, 1 times a is a, plus 1 times b is b, plus c. So now I have a second equation. 5 equals a plus b plus c. And here in a bit, I'm going to call that equation 2. And one more ordered pair to use in this process, right? Ordered pair is 317. So I'm going to repeat the process one more time. Every place I see an X, I'm replacing it with 3. Every place I see a Y, I'm replacing it with 17. So Y equals 17 equals AX squared. So A times 3 squared plus BX, B times 3, plus C. And clean it up. 17 equals 3 squared is 9 times A is 9A plus B times 3, 3B plus C. Okay, guys. And guess what I'm going to call that? I've got equation 3 here. So I don't know if you guys realize what I did, and I'm getting ready to rewrite them over here so we can work with them. We've got 3 equations. And previously we've seen it as x, y, z. In this particular setup, we're looking at a, b, c. Do you see where we're going with this next? Okay. This is what we looked at last chapter, the end of 1.6, I think it was, where we had to pick substitution or elimination to solve. So I'm going to bring my equations up here, put them all next to each other, and then we're going to go from there. So equation 1 is going to be 4a minus 2b plus c equals 32. Equation 2 is a plus b plus c equals 5. And equation 3, 9a plus 3b plus c equals 17. So let me put some numbers on those. Equation 1, equation 2, equation 3. Okay, guys. Officially, it's elimination or substitution. Me personally, are you guys okay if I take the elimination route? Okay, I feel like that's what more people do. I feel like it's kind of what it's set up to do. However, I'm not saying you can't do substitution, because that is definitely an option here. What variable would be easiest to eliminate?
C.
C. Okay, now, here's a hint. C is going to be that answer all day long, because all of our equations in this standard form are always going to be plus C. Now, in order to eliminate C, the way I teach it, what am I going to suggest we do? What? Multiply one of these equations by a negative. Okay? Officially, it doesn't matter which. But so if we say want to put equation 1 and 2 together, I'm going to say multiply one of them by a negative. I personally am going to pick equation 2. I have my reasons. I just like it. So I'm going to take this equation here, and I'm going to multiply it by negative 1. Okay? Then we're going to bring these two equations over, and we're going to put them together, and we're going to work with them. Okay? So it's still equation 1 and equation 2. Equation 1 is staying as is. 4a minus 2b plus c equals 32. Equation 2, if I multiply it by negative, everybody changes sign, yes? So it becomes negative a minus b minus c equals negative 5. My c's have opposite signs, yes? So I am ready to add. 4a plus negative a is 3a. Negative 2b plus negative b is minus 3b. C plus negative c cancels. 32 plus negative 5, 27. What am I probably going to call this? Equation 4, yes? This process, you already know this process, folks. You know how to finish this problem. Okay? I'm not changing anything up. So, yes, this is equation 4. Okay? How would you like to find equation 5? What would you like to put together now? You know we have to use equation 3. Easiest in my brain. Could we use equation 2 again, that we already multiplied by a negative? That would be my suggestion. We already have one multiplied by a negative. You're going to have to do this every time, folks. Multiply one by a negative and use that with the other two. It's going to be the easiest thing. So at least that's my opinion. I'm going to bring it over here. I'm going to use equation 3. And I'm going to use this version of equation 2. So equation 3 is 9a plus 3b plus c equals 17. Equation 2, multiplied by a negative. Negative a minus b minus c equals negative 5. And again, my c's are opposite signs, yes? So put them together. 9a plus negative a is 8a. 3b plus negative b, 2b. C plus negative c, cancel. 17 plus negative 5, 12. And I'm going to call this equation 5. Okay. Now, do you remember what to do next? We're going to take 4 and 5, and we're going to work to put them together, yes? At this point, we've eliminated C. And that's going to be usually your first job, eliminate C. Now, I want to eliminate A or B. Which one would you guys say to eliminate? B. Now, we can go the traditional route with how we eliminate B, or we can change it up a little bit. What options do you guys see to get our B's to have the same coefficients? Traditionally, if you see a 2b and a 3b, what are you guys probably going to tell me to do? Turn them both into 6b's? Okay, that's one option. I could go with that if we want to be traditional. Did anyone notice anything on equation 4? What's true of all terms in equation 4? They can all be divided by 3, yes? And that would take that to a negative b? Just hold this thought. What's true of all terms in equation 5? They're all divisible by 2, yes? And that takes that to a positive b. Now, here's the deal. Whether you take these to 1b's or 6b's, are you still eliminating b? You are. What's the advantage of going for the 1b's? You get some smaller numbers to work with. Am I saying you'd have to? No. Are you willing to try it with me? Or do you guys want to be traditional and go for 6b? I kind of want to show it and try it. Okay, now, if this doesn't work, well then, you know, so be it. And is this going to necessarily work every time? Not necessarily, no. So let's try this equation. I'm going to go divide by 3. And we'll take it down below. This equation, I'm going to divide by 2. Okay? And so these equations, hopefully this doesn't get too messy, I'm going to bring down here. And of course, these are equations 4 and 5. So equation 4, when I divide it by 3, becomes A, 3A divided by 3 is A, minus 3B divided by 3 is B, equals 27 divided by 3 is 9. Equation 5, when I divide it by 2, becomes 8A divided by 2 is 4A. 2B divided by 2 is plus B, equals 12 divided by 2 is 6. That math is looking pretty nice to me. Okay. If you multiplied by 2 and 3, that is perfectly fine. That's not wrong at all. That is great. That is what I've previously taught. And that's what will always work. The dividing just happened to work this time. Okay? Okay, my B's have opposite signs. Minus B plus B, so we are ready to add. Let's see what happens. A plus 4A is 5A. Minus B plus B is gone. Carry down my equal sign. 9 plus 6 is 15. Well, if 5A equals 15, what do we know? Yep, divide by 5. And A is 3. Okay. I've got one answer, yes? We know A. Let's find B or C. How do we normally find the next variable? Okay, we plug it back into 4 or 5, yes? Now, doesn't matter. You have options here. Could we use the original 4 and the original 5? Yes. What about this 4 or 5? Could we use the 4 or 5 that we had divided? Normally we don't because we've multiplied and made them bigger, but didn't we divide these and make them smaller? This would work as well. Okay. You want to try equation 4? I guess I'm moving back over here. Oops. Okay. So equation 4, and if you want to use the original version of equation 4, have at it. You'll get the same answer. Barring no math mistakes, you'll get the same answer. So, A minus B equals 9. We know A is 3. 3 minus B equals 9. If I want to get B by itself, I'm going to move my positive 3 over. Means I'm going to subtract 3. Negative B equals 9 minus 3 is 6. Watch your 6's and B's. They're as bad as 2's and Z's. Okay? And if negative B equals 6, then what do we know B is? Negative 6. That's multiply or divide by a negative 1. Okay. I know A. I know B. What am I missing? C. What do we traditionally do to find C? Go back to 1, 2, or 3. I say 2 looks easiest, doesn't it? Golly gee. I didn't. Okay, so 2 is A plus B plus C equals 5. What do I know? A is 3. B is 6. Plus C is 5. Like terms, 3 plus 6 is 9. 9 plus C is 5. To move the positive 9, I'm going to subtract 9. And C is 5 minus 9 is -4. Okay. Huh?
It's A plus B plus C, and you put, and our B is a -6, right?
Yeah. So, hey, guess what? My answer key disagrees. C is not -4. So thank you. Okay. Did anyone else do better than me, I hope? Or did you guys all follow my mistake? Okay, well, hey, I like that answer better. Or at least my answer key does. So, yep. Okay. Sorry, guys. You can't always trust the teacher to not make mistakes.
I think you were just checking this.
I was. Who was going to catch me? Since them caught me, you had to speak up. I'll take it. Okay. So 3 plus -6, or -6, plus C equals 5. Dang it. 3 minus 6 is -3, plus C equals 5. If it's -3, we're going to add 3. And now C, hey, guess what? C is 8. Okay, guys. If you got A, I hope that eventually you would have figured out that you couldn't find your mistake and you saw my mistake and you would speak up. So, okay. Now, we have one last task to do. And that is write our final answer. Okay? Slight difference here. Last unit, we were trying to solve the system of equations. We needed an ordered triple, yes? What was our direction here? Write the equation of a parabola. The equation of a parabola is y equals ax squared plus bx plus c. What can we do? We can write that equation and fill in our ABCs. Yeah, so fill in your ABCs. Y equals ax squared, so that's going to be 3x squared, plus bx minus 6x, I got that time, plus c is plus 8. And there's your final answer. That's what Savas will be looking for. The equation with A, B, and C filled in. Okay? That problem took a while, didn't it?
I need an entire page for that.
Okay, guys. The process is familiar, yes? Okay. This process is not new. You have an intro part that's new. Some different things popped up that we could do, but the process is not new. How you express your final answer is new. Okay? Practice with one more. Let's try it, folks. Okay. Yes, we have some of the numbers are a little bit bigger. I never feel guilty if the numbers get a little bit bigger, because what can you always grab at this level? You can always grab the calculator, right? So, you know. Okay, so let's write an equation of a parabola. Filling in the form, y equals ax squared plus bx plus c. And every time we're giving an ordered pair, remember it's in the form xy. So let's grab our first xy. And I write out the extra steps right now. By all means, you can, shorten your extra steps a little bit. So xy, y equals, so negative 12 equals a times x squared, a times 2 squared, plus b times x, b times 2, plus c. Clean it up. Negative 12 equals 4a plus 2b plus c. That will be my equation 1. Repeat the process. Now I'm using the ordered pair. Negative 1, negative 15. And again, you're given x and y, right? So y equals negative 15 equals a times x squared. So a times negative 1 squared plus b times x, so b times negative 1 plus c. Negative 15 equals, now, negative 1 squared is what? Negative 1 times negative 1 is positive 1, yes. 1 times a, 1a or a. B times negative 1 is going to make this minus b plus c. That will be my equation 2. And then equation 3. Using negative 4, negative 90. X and y. So, y equals negative 90 equals a times x squared. So a times negative 4 squared plus bx. So b times negative 4 plus c. Negative 90 equals negative 4 squared is going to be positive 16. So 16a minus 4b plus c. Okay. Slightly bigger numbers. Again, it's all right. You're allowed to use a calculator. Always calculators up here to borrow if you need them. Now, and some of you will shorten this up and you just went ahead and wrote your equations, didn't you? You didn't go through the extra step of writing it out. That's me as a teacher writing them out. So I'm going to have 4a plus 2b plus c equals negative 12. That's going to be equation 1. A minus b plus c equals negative 15. That's going to be equation 2. And 16a minus 4b plus c equals negative 90. That's going to be equation 3. So I've got equations 1, 2, and 3. Hey guys, guess what we're set up to eliminate? C's. It's plus C every time, isn't it? So now do you see why I say we're going to be eliminating C's every time? Well, you can eliminate C's every time. How's that? I don't know what you're going to be doing, but we want to do the same type process as last time. One of these, multiply by negative and put it with the other two. I'm guessing, let's multiply negative 2 by a negative 1. Let's put it together. So equation 1, I'm just going to rewrite 4a plus 2b plus c equals negative 12. Equation 2, multiply it by a negative and everybody changes. Negative a plus b minus c equals positive 15. My C's have opposite signs, positive C and negative C, so that means I am ready to add those opposite signs. 4A plus negative A is 3A. 2B plus B, 3B. C plus negative C, cancel, equals negative 12 plus 15. It's 3. It's a lot of 3's, isn't it? Okay. In all honesty, folks, if you wanted to go ahead and divide that equation because you see that everybody can divide by 3, you could do that right here. Now, I personally am just calling that equation 4. If you want to go ahead and divide it by 3 before you call it equation 4, that's your prerogative. That would work. Okay? Repeat the process. This time we've got to use equation 3. And easiest is probably just going to be to reuse equation 2. My opinion, of course. So equation 3, 16A minus 4B plus C equals negative 90. The equation 2 multiplied by a negative became negative A plus B minus C equals positive 15. Okay. My C's are opposite signs, so I'm ready to add. 16A plus negative A. Negative 4B plus B. Negative 3B. C plus negative C, cancel. Carry down your equal sign. Negative 90 plus 15. Negative 75, I believe, if my math isn't failing me. And I'm going to call this equation 5. Now, could this one also divide by 3? It could, and you could use that version of equation 5. What do you notice about equations 4 and 5? What? They both divide by 3. And if we divide them by 3, you're going to get 1b and negative 1b, yes? Or, could we actually put them together as is? We already have a plus 3b and a minus 3b, don't we? Now, the differences. If you divide them both by 3, you work with a little bit smaller numbers. If we leave them as is, you have a little bit bigger numbers, but it works out the same. Okay, I know I'm giving lots of choices, which is not always great the first time I teach something. However, this isn't really the first time I taught this. So, okay, make adjustments with what you want to do. I'm just going to use 4 and 5 as is, I think. I don't need to do the extra divide by 3. I guess there's one place it'll come back and possibly bite me, but yeah. We're just going to use 4 and 5. So 4 is 3A plus 3B equals 3. 5 is 15A minus 3B equals negative 75. My B's have opposite signs, so they're ready to add. As I said, we have a little bit bigger numbers here. Maybe this wasn't the best idea, but it'll work. 3A plus 15A. 18A. 3B plus negative 3B cancels. Equals 3 plus negative 75. negative 72. Okay, this is the one part I regret because now I have to think extra hard about how many times 18 goes into 72. I can do it, but I have to think extra hard about it. So the other one I've definitely all done in my head, but that's all right. Negative 72 divided by 18. Is it negative 4? Okay. So there's my A value. And double checking. Hey, guess what? My answer key likes that answer. Okay. Just like last time, there's not just one right way to do these, right? There's lots of twists and turns you can take. Okay, once we know A, what are we probably finding next? B. Okay, it's kind of the, it's A and B we find first. We'll find C last. Yeah, this is where I don't have a smaller equation to use, do I? But 4 or 5. I'm going to go with 4. Equation 4 is 3A plus 3B equals 3. So 3 times negative 4 plus 3B equals 3. 3 times negative 4 is negative 12 plus 3B equals 3. If you get 3B by itself, how do I move negative 12? I'm going to add 12. So negative 12 plus 12 cancels. 3B equals 15. Divide by 3, and B is 5. Okay. I've got A, I've got B. You need C? Go back to probably equation 2 if I had to guess. Okay. You're going back to whatever equation makes you happy there. So I'm going to use the original 2, which was A minus B plus C equals negative 15. So negative 4 minus 5 plus C equals negative 15. Negative 4 minus 5 is negative 9 plus C equals negative 15. And if it's negative 9, I'm going to add 9 to move it. Negative 15 plus 9 is negative 6. Did I succeed that time? Okay. Not an ordered triple for your final answer, but standard form, yes? So standard form being y equals ax squared plus bx plus c. So what do I have? Y equals negative 4x squared plus 5x minus 6. Okay. Now, good news, these go quicker on your own, right? Okay. I believe, if I recall correctly, homework is, guess how many problems? 3. Okay, same thing as what we had last chapter. 3 problems. Okay. Let's see, I'm trying to remember if that happens in homework or not. On occasion, you get a nice one where when you're creating equations 1, 2, and 3, you end up finding out C right off the bat. And if you end up finding out C right off the bat, my recommendation will be take C and plug it into your other 2 equations, and then you'll just have A and B to work with from there. Okay, we can talk about that tomorrow if we need to. Okay, make sure you spend time on the homework. Make sure you guys get it done. If you have questions, you want me to troubleshoot something, please stop by and see me. I will gladly troubleshoot. Same thing as last time.